Good. I'm sorry, I just started the recording. So the early question here is: are we using what am I using for the test, right?
Yes.
And
I'm wondering if you're going to be using those, like the arm, the that the plastic body and the hip,
yes,
legs, and all that. The joint.
yes, I'm gonna be using all the models that we have been using in class.
Okay. It's good to know.
Well, yeah, it's good to come to class.
Oh yes, yeah, oh yeah.
So yeah, and this week we will have today and then Thursday. Wednesday the school is closed, but today it's open. They don't celebrate the indigenous. I called them. I didn't just look it up online. I actually called them. Not that we're standing there and all of a sudden it's like, no, we don't have any class. But we don't. We do have class, and so there is a lab at 6 o'clock tonight. If you are in the Wednesday section, I urge you to please. Well, it's up to you at the end of the day, but I urge you to come either Monday or Thursday, because we'll definitely spend the time. I have a feeling going through models and trying to get prepared for next week, and then next week, Monday, Wednesday, and Thursday is the test. And so
All
then,
right.
you come to your lab. Although if I have a couple of crossovers, that's not a problem. That won't be a problem. Just don't everybody show up on Monday or on Thursday and not on Wednesday. But next week is the test. And on the test, you can use a term list, as I've been mentioning a lot of times in the class. And you can actually make a cheat sheet out of that term list. And so you can use one that you bring from home. You can't use more than that one sheet, but you can go front page and back page and put on that thing whatever you need to organize your material and understand. And then we go through the test. And on the test you're going to have the term list, and you're going to have an answer sheet that I create and I'll give you, with lines on it and numbers on it, and then numbered, these little dots that we use for the posture evaluation. They have numbers on them, and then those numbers will be on the model. And then each station, then I have dividers, and I make the tables go in a U-shape kind of form. And then each table has these dividers on it, and we move from station to station. And so you have little cubicles where you're by yourself. And then on within those cubicles, there's two questions. There's two numbers, and the questions I'm asking is three things. I'm asking bones, and then I'm asking landmarks, and the landmarks are smaller parts of the bone. For example, the frontal bone, and then the glabella would be between the eyebrow landmark. And then the third thing I'm asking is muscles. And so those three things you're responsible to know. You're not responsible for doing action, insertion, origin. You just need to label the muscle that I'm pointing to. And you're going to get 2 minutes per station. And then once we're all the way around, the first time, that's just to keep order. Then you can go back to the stations that were difficult, or you have extra questions. And of course, you can ask me questions. I'm just not going to give you the answer. But I'm going to guide you potentially through confusion, so that certainly is helpful. And I'm going to be there the whole time until you guys are finished. So you should have plenty of time for all the ones that are not clear and that you want to clarify.
Thank you.
You're welcome. That help?
Definitely. Very helpful.
Yeah, we're going to go through that again tonight, I'm sure. Any other questions, since we're working on questions here first?
So this week we have lab Monday and Thursday, not Wednesday, right?
Yes, and I called the school. I didn't just look it up. I also called them. So we do have lab tonight, but not on Wednesday. So if you're in the Wednesday section, please, please, please take advantage and come Monday or Thursday. We're going to go mostly, I think we're going to mostly go through the material. I'm not going to get new material going. We're going to just figure out how to consolidate the later labs at some point. But this week, we're going to do review of the material, and I'm here to answer any questions. We do some drilling, and then you guys should be ready next week for the test. Okay? Well, good. If nobody's responding that here, then let's go right into this week. And if you have any questions, just um, interrupt me. And I can't read the text. I'm here on Safari. So just interrupt me if you have any questions regarding anything, including the test. So actually, if I go through here real quick on the test review, you want to make sure. Oh, it's probably a little slow. I have too much stuff open. Make sure this is where the term list lives. If you haven't gotten one from me, and I should probably print out more term lists. I'm sure tonight people want term lists. And then the second thing I have here is review videos. And those are actually pretty good to watch, I think. And they're old, so they're a little bit more extensive in the terms than on the terms on the list. You're only responsible for the terms on the list. But these review videos just kind of passively, you go, well, not passive, but you can watch them. I say passive because I remember this one person is like, oh, yeah, when I watch them when I do laundry. And so in the background. But these videos show you me basically pointing to all the different parts that we're working on. And so it sort of goes, right, this is this, this is this, this is that. And so it should be pretty swift, and it's probably a good place to go when you're sort of familiar with it, to kind of finish up your studies. And I'm using these models that are on those videos. And then the last one is possibly an interesting that links to, I'm not going to open it because it's not going to get there, but that links to pictures of all the models. And so that's probably not the greatest to print out, use a lot of ink, but it could be helpful potentially to look at what are the models, to have some visuals with the models, and you can kind of, figure out yourself, go down the list and say, this is here, and so forth. And you're not using pictures that then I don't use on the test. These are the pictures of the models that we're using on the test. All right, good. Enough on that. Now let's go through this week. Well, we have to be moving forward. So we're only, you guys sort of get a grace week before for the test because we have this professional development day this week. So I can't do the test this week. But we move forward on the online material with going into the heart. So I know it's parallel a little bit, but you have to just do it, and go with the thank you. I get an extra week to study. But this week we're going to cover the heart, the blood vessels, and the lymphatics. And the heart is sort of a combination. The anatomy now becomes a little bit less vast, it seems, as we're going through all the muscles and all the bones. So that's really the big anatomy sort of test. Now we're having us a bunch of chapters that have some anatomy to it. It's all very slow, but then it also talks a lot about the physiology and how things work, and how the heart contracts as one unit, and who talks to the heart to contract, and how does that work, and how does the blood go from one place to the next place. And the heart is an interesting organ. It's two pumps in one organ, and so it has a left and the right side, and the one side gets the blood from the body, from all of the body, and pumps it into four chambers. So each side has two chambers. Four chamber where the blood sort of trickles in, and then it has a main chamber, or an ejection chamber, they call that, where when the heart contracts, the liquid, the fluid inside those chambers, when it's squeezed, and the heart squeezes the muscle, that means it gets shorter. The muscle squeezes the chambers close, and that forces the content of what's in there out into the aorta or the pulmonary trunk. And so the right side will then, the blood that is used up, so to speak, meaning the oxygen is gone, that goes into the lungs and get reoxygenated. And then the left side of the heart gets that blood back. And when that main ejection chamber pumps that other side of the heart, then that feeds the blood to all the organs in the body. And and then feeds the whole all the tissues, not the organs, all the tissues of the body, and feeds those tissues with nutrients, but also heavily with oxygen. And then oxygen is used. We use oxygen to harness the ATP to get the energy out of the glucose or out of the food molecule, the macromolecules, the carbon chains. At the end of the day, is where we get the energy from. And so that talks about all of that. So there's a cardiac out cycle, which is like, how the blood travels through the heart, which I just kind of talked a little bit about. There also is heart sounds, because we have doors or valves that close the chambers off from one another, so the blood doesn't move backwards; it moves forward. And the sounds of the heart that lubbed up that we can hear with a stethoscope, that is those valves closing. And so it's some pretty interesting stuff. It's a good chapter. It's actually the one chapter I had a TA write part of it. It was like she wanted to, and she was able to present it. I mean, I rewrote it at this point, but originally we did that together. So there's still some remnants from hers. That was cool. Geez, time goes fast. And then the second chapter goes to the blood vessels. And I'm not making you memorize all the different names of the blood vessels. I make you, because a lot of the blood vessel names they're named by, oh no, it doesn't show here. They're named by where they travel to. So they travel by the axilla, the armpit. They call them axillary arteries. They travel down the upper arm. What you call that? The brachial artery, and so forth. And so they often travel by the area that they're named by the area they travel to, or also by the bone that they're traveling to. I just realized my computer is almost out of battery. That's not good. That's not good. Where is my battery pack? Oh, here it is. Oops. All right, in case I need some extra juice. And what we look at here, though, are the walls of the blood vessel. That's one thing we're looking at here. And when we look at the walls of the blood vessel, then we start differentiating between arteries and veins. And you probably heard of the term arteries and veins before. And the arteries they're often the ones that look red, and the veins are the ones that look blue for the most part. But the color is representing how much oxygen is in a vessel. It's not representing it's actually an artery or a vein. It just happens to be so that they are mostly matching. The one place where they don't match is when the blood goes from the heart to the lungs and back from the lungs to the heart, because the artery's definition is a blood vessel that moves away from the heart. Because if you think about the heart's a pump, so when you pump that blood out of the heart, it has a lot of force, hydrostatic force, and that means the vessels that receive that forceful blood need to be very flexible and need to have a little bit of a different construction than the other side, which are the veins, which is the blood that comes back from the body and brings the blood back into the heart. There is, the heart, that blood pressure, that hydrostatic pressure from the heart pumping, by the time we get to the veins, that's gone, because the blood needs to be seeping into the tissues and feed the tissues with oxygen and with nutrients and pick up some waste products, and then the blood just kind of trickles back out of those tissues, and a lot of that is actually done with osmotic pressure, which is like, when you put a salt on a tomato and the water, also the salt kernel is replaced by a droplet. Well, that's the salt pulling the water out of the tomato. And it's a similar concept with pulling the blood out of the tissues, because some of the larger components of blood, especially albumin, is a protein that is not seeping into the tissues, but it is staying into the blood itself, and then that becomes a pulling force. Those molecules become a pulling force for the blood coming back. The other thing that helps with the blood coming out of the tissues is going to be the lymphatic vessels. And that's its own chapter a little bit. We do look, it's just a small one. We don't really do big on the lymphatic vessels. But the lymphatic vessels are are one-ended. They're open-ended. No, they're one-way sort of fingers. So vessels like fingers, they go into the tissues and have their fingers poke into the tissues, and they have little slits that the fluid can come in, but can't go back out. And then from there, all the lymphatic vessels pick up the fluid from all the tissues and dump it ultimately right next to the heart into the venous system right up here, and return part of the blood that way. We know the lymphatic system from spreading cancer around. That's sort of the negative, because the immune system is represented in the lymphatic system as well. And there's at lymph nodes, these little nodes here, these little dots, these are lymph nodes, and the immune system sits in there, and that's also how the cancer can move around. So that's where we colloquially kind of know that from. But generally, it's a cleaning system, and which makes sense. You clean the used up fluids. If you put some immune cells around and make sure there's no bad stuff in them, and if there is, we can neutralize it, viruses or so forth. That's kind of very positive for the most part. So that's sort of how we get the blood back out of the tissues into the veins, and then the veins travel. Often they travel deep in muscles, and as we use the muscle squeezes the veins, and then the muscle squeezes the veins, and then that pumps. See, that pumps the blood towards the heart. Usually, the reason why it pumps it towards the heart is because we also have valves in the veins, and the valves open towards the heart. They don't open towards the feet or the hands. And so this is actually an important reason why we want to be, this is the soleus muscle. We talked about that last week in class, in the calf. This is why we want to use muscles and not just sit around all day, because we got to get that blood moving. So literally, when we move, we really move the blood. And so the veins, the walls of the veins, they look different. They're much baggier. They're skinnier, sort of look, and they kind of guide the blood back towards the heart. Look, the slide here is pretty strong, I think. See, the veins is like not round. The artery is usually round. The veins like a little different shape depending on where we are, and it's not as thick, or it's not as much, has muscles in it, not as much, and not as many collagen fibers, elastic type fibers as well. See here, we could see there it says elastic. There's elastic fibers in here, and the elastic fibers. There's also elastic fibers here. You have much less elasticity to the vein because you don't need it. The blood pressure needs the veins, the arteries, to be sort of bendy a little bit or extending a little bit, expanding, but then coming right back to keep their shape, and also to not just pool the blood somewhere where we don't want it pooled, to kind of move the blood along as well. Because if you stretch, if the hydrostatic pressure, let's say, goes over the aorta and it stretches the aorta a little bit, every pump it comes out, and then the aorta recalls, that pushes the blood further down to where it needs to go, especially the one going up the head, because that's against the gravity. So the blood vessels is an interesting chapter too. I think personally, at least I try to make it as interesting as we can. And then from there, we have questionnaires that go together with these chapters. So you're going to go through those. And then we're going to label the heart. And I got to start talking about the pathology project. Yeah. So we're going to label the heart. And then we also have a discussion about the injury prevention eval. How did that go for you guys? Any comments on that?
I think it was a little hard to remember to do it, but I've been doing them. As I was saying in the week 8, I was like, man, I had a nice routine down. I thought I was doing really well, and the next thing you know, I forgot. Like on a Wednesday, and then a Thursday, I was like, oh crap, I had too much going on. But yeah, but I still do like doing those ones. I like the backward shoulder rolls, the Brugers. Really position is really nice because it feels really tough to do at first, but when you stop, it feels really good.
No, it does. And then the injury prevention is a pretty long thing. I know I kind of feel bad to torture you with that, But on the
Oh,
other
it's
hand, I
okay.
also feel like I do it and I want to keep it, or I keep it because it's actually extremely useful. Uh,
I think so too. Yep.
that's it's the real stuff. I got this from the orthopedic literature and from us. We're usually trained in doing these evaluations with the patient. It's stuff, and I just figured, it's not that hard to do. We can put it into a class, especially when we learn all these muscles and all that. And so, feel free to share that stuff, because
Mhm.
it's definitely from the orthopedic literature. They do that same
Yeah.
tests for the Olympic team and the Swiss team. I know that because I know the clinic that does those things. And so these they call them functional capacity evaluation, because you're doing a functional thing, and you have a normative data, and you see what's your capacity. And also like the fact it's not just strengthening, it's also the stretching is also involved in that. And so, yeah, keep those things handy. They might be come in handy when you want to go play some soccer in your 40s later on. That's when people get
Oh,
injured.
definitely.
The
Yeah.
weekend warrior people, that's when we get injured.
Oh, yeah.
Yeah,
You
no,
ain't kidding. Yeah.
yeah. Well, and of course, I probably do this stuff also selfishly. So twice a year, I'm kind of doing it myself, to keep up. So we're gonna have a little discussion around that thing to finish up that process, and then uh, thank you for all doing the physical stuff. So we do have more health kit things coming around, but we're gonna do some salt monitoring our salt intake next week, not this week. After the heart's finished, because that's a blood pressure question that we often have. Is salt is a very important constituent to high blood pressure, and we love our salt. So monitoring it a little bit is interesting because salt's an adaptive sense, and so it's something you get used to. So we get used to more, which is evolutionarily. If you think about all the stuff we need sodium in, it's tons of stuff we need sodium in, and so we do need a plenty amount of sodium, but it wasn't available in the old days, and then of course now it's plentiful all over the place, and so that's why we have that craving for salt. And so it's one of those things that certainly behooves us to be a little bit more mindful about, or we can do a lot without even noticing it. We just have to trick our brain once in a while. um, and then another one we're going to do is a gratitude journal when we get to the brain. So that's also interesting, looking at things that make us happy versus just always complaining about everything that's out there. And because that actually changes the brain, and you fake it till you make it. So you the positivity will make the brain more positive, the negativity will make it more negative. We'll talk about that in the brain, that sort of neuroplasticity right there. And then the last one, I think, one of the no then we have a food journaling, and then we have an eye vision thing. That's at the end of the semester. But the other thing we're going to start doing now is a pathology project. And I should probably open that tab as well. And I'm going to do those in lab for the most part. But you also will probably have some work at home. So the first thing we're going to do in lab, and we probably do this week. Yeah, we should do this week. We're going to form groups of three of you guys working together. Um, and then each of the group, and ideally those people you're seeing in lab, you're working together in lab, so it's sort of cohesive that way. But then each of the group will choose a disease process of their liking, or of their choosing. I mean, some people have a strong proclivity, like a family member had something, or they are struggling with something like back pain, or a diabetes if it's older people, or high blood pressure or something like that. And then we choose a pathology, so one per group, and I kind of have to approve it to make sure we don't have the whole class do the same one. And then from there, we're gonna start with researching that pathology. And I want to research each member of the group. I want them to research one question. And the first one is, what is the pathology? And so you go a little detailed, of like the path, what makes this happen? Why is this happening? What is actually the physiology, or the pathophysiology of the pathology? Who gets it? all those kind of questions. And then that's like when you start, you go up and look at some Mayo Clinic. You look at, I think I wanted to look at 5 different sites, I think, each person, something like that. So it's not just like one site and you just copying down that site. And it's usually, often it's not necessarily that comprehensive, especially if it's a site that wants you to sell something. But I usually start with Wikipedia, actually, and then that's not a bad one, and then go to things like Mayo Clinic or so. And I want you to use 5 sources for each person or each question. So what's the pathologies one? And then the second one is like, what is conventional medicine going to do for you on that pathology? So that, like, diabetes, they give you metformin or something, or maybe Ozempic at this point. And then with back pain, they give you ibuprofen, they give you, muscle relaxers. Nothing wrong with that. But what's missing about that is, what can you do to support the medical treatment with lifestyle and changes and or alternative interventions? You'd be surprised how alternative intervention I'm still am as a chiropractor for some of these MDs. And it's, then they send them potentially to surgery when it's not even necessary, because we just haven't looked at all the pieces yet that could help. And so I want to have a little research in that. The reason why I started this is, I have one student and she missed the test, and it was like, so can I make it up? And I said, like, well, why did you miss the test? And she said, my son had an asthma attack and I was at the ER with him. And I say, oh, well, what did they do for your son? He said, well, they gave him an inhaler. And I say, well, did they also talk to you about things like that cause the asthma attack, like, milk products, like cheese, the stuff that creates phlegm, or a lot of carbohydrates, all the processed foods like that, they are inflammatory. They cause these things to come on. And she said, no, not at all. They just gave us an inhaler. And I'm like, well, maybe that should be your project to give me sort of the third question. What can you do to help your son out more versus just doing what the doctor says? Um, and these days we have a lot of options, we have a lot of possibilities. We can go and do some research online and find things that we can help, but makes us more empowered, not as like, it's nice to park our liability responsibility in a doctor's office, but the problem is, if it ain't going to get fixed with that, you're still in your own body, or we're still in our own self, and we got to live with that. So we might as well take advantage of our knowledge that we're building, and then also reading research a little, or different things, and start figuring out what makes sense, what doesn't make sense, because you get a lot of input, too much input in many ways. We have to sort it out. And so that's what I want to do with that question. And so each person then will have one of those 3 questions that they research on, and then they make a presentation, like a Google slide or a PowerPoint or something like that. And usually, and I want each person to work on making a presentation that's about 3 minutes long, like very short, like sort of elevator speech level short, down to the essence. Although, of course, then I'm also going to tell you, work with a story, because if you present with a story, or with a reason why versus just data points, and you rattle them off, well, everybody will fall asleep. Believe me, I tried that many years. Everybody fall asleep. You got to sort of be, so it's an exercise in researching some, but then it's also an exercise in making a captivating your audience, kind of thing. And so I want to work with you guys together. I figured at some point I realized I have some experience in that, so I might as well pass along what I kind of know as much as possible. And so you work on a presentation, again, 2 3 minutes, 3 4 minutes long max. Make a you can also, me going back to the classroom, so you can actually make a board. You don't have to make a PowerPoint. You can make one of those folding boards that you used to have in high school, or so. You can be creative in that process. I even thought the other time, making an infographic, or like a scroll type approach. Something that also originally I thought we make brochures, and then everybody gets a brochure from the other person, and I had to make brochures, actually. and maybe I will do that again. And then everybody gets a brochure from the other person, and everybody then has much more knowledge about these things, for multiple pathologies, not just their own. And so infographic is a perfect thing. Like Canva.com is a great place to work with infographics if you're into that kind of stuff. I should share one with you that a patient of mine made on some really cool Alzheimer's stuff that I still have to kind of figure out what's really what, but it's a great little infographic, so I can share with you in class. And then we go over this presentation a few times, and this first we do a draft, and I critique it, then we talk about it, and then you revise it a couple times, and then last thing what we're going to do is we're going to present, and we're going to have us a couple of labs where or maybe one lab is enough to do it in 3 days a week, where the groups will present their presentation to the rest of the class. And so we also learn a little bit of what it feels like to present. Now I understand that might be a little scary, but at the end of the day, it's actually a lot of fun. Most presenters have a good time. And at one time we even had a group they were deaf. They didn't speak. They had sign language. And so we had interpreters in the classroom. That was a couple of years ago, or maybe a year ago, actually, a year and a half. We have interpreters in the classroom, and they would do sign language, and then the interpreters would speak out what they sign. So that was really cool, and they had a lot of fun doing that. Actually, I have a video of that. I have a YouTube on that. So that's sort of the process that we're doing through the rest of the semesters. Now that I'm just kind of springing it on you as a project. This is a lengthy project. We have these weeks will probably shift a little bit, but we kind of have like a 6 weeks length of project. So this week, I would like for you to choose a group when we go to lab, like who to work with. And then I can also work in the background and help in the background with that. And then also, I want you to start figuring out what pathology would you like to do? What disease process would you like to do? And come up with a couple ideas on your end, and then we can start working in the group. And then those are the first 2 steps. That's all I want you to do for now. Is that better? Hello, did I lose all? Oh, did I lose you all?
I'm still here, but I think it's so far I hear
better.
you.
Okay, you got the point. You got the point, right? This week.
Yes, we hear you. We hear you.
Yes.
All right, good. Okay, because to me, we can finish here if there's no other questions. I'm pretty much said what I need to say.
I do have a question.
Okay, go ahead.
Tonight, I've never been. I only come on. I'm usually Wednesday night, so I'm gonna come tonight for class.
Good.
You still in the same classroom, right?
Yeah, it's always the same classroom. Yes.
Okay. All right. That's all I wanted to know, Doctor.
Okay, great. Thank you for asking.
And I guess for the Wednesday people, should we choose people Monday night or Thursday night?
Yeah, that's yeah.
Just show up when you want. Just come when you want. Yeah, one or the other. I don't care which one. Make it if you can make it. I'm grateful for that.
Okay, and then for our groups, then do we just wait till next Wednesday? Like if we're the Wednesday class, do we wait till next Wednesday to choose a group, or do we just like?
Yeah, we'll see who shows up on the same day, and then we could do that, or we can finalize it next week.
From there.
Yeah, we go from there.
That's fine.
Okay.
Good.
Also, for the questions, you said we're each going to pick one of those 3 questions, like what is pathology or how does conventional, and then if we research the same sites, is that okay, or do you want us to separately do different like websites?
No, I want to individually in each use 5 sites, but they can potentially be the same site. But not like, but I want you to pull information from 5 different sites. That it's more balanced. It balances more what you present. Yeah.
Okay.
Okay.
Alrighty. Thank you.
All right. Thank you, guys.
See you guys tonight.
See you guys tonight.
Right.
Thank you. Bye.